The idea of space travel has captured human imagination for centuries. However, the reality of space travel is much more complicated due to technical limitations. The current limitation in space travel is the propulsion system used in rocketry. Even when we have high-end rockets that can accelerate more rapidly, traveling beyond our moon or Mars is always a difficult task. This is where ion engines can change the game. NASA predicted that it would take 7 months to reach our closest neighbor, Mars, using the conventional method. This is why sci-fi writers often invent powerful engines on their spacecrafts that allow humans to cross large distances in days or minutes, rather than months or years. However, scientists and engineers have been working tirelessly to develop new propulsion technologies that will enable us to travel faster and more efficiently through space. One of the exciting new technologies in space propulsion is the ion engine. Scientists predict that this could be the key to faster and more efficient space travel. Ion engines are different from conventional chemical rockets. They work by creating charged particles, also known as ions, which are then accelerated using electromagnetic fields to very high speeds. The greater the electrical energy applied, the more momentum the charged particle will have, which in turn produces thrust, making the spacecraft move forward. The principal advantage of using ion engines is their remarkable efficiency compared to chemical rockets. Conventional rocket fuel efficiency could achieve up to 35%, while ion engines could achieve 90%. Moreover, ion engines can continuously accelerate for years. The increased acceleration adds up and enhances the top speed of any ion engine-propelled spacecraft. This technology is still under development, but there are examples of its use in outer space missions right now. There are various types of propellants used in ion engines, such as xenon and hydrogen, that are already being used in different types of engines. For example, NASA's DART mission was equipped with a next gridded ion thruster, ready to be used if its conventional thrusters failed. This demonstrates that the technology has been tested and the effectiveness of ion engines is already proven. Ion engines are emerging as the key propulsion system to travel beyond Mars and even further into deep space. The advantage of an ion engine is its significantly high thrust-to-weight ratio compared to chemical rockets. While chemical rockets can generate massive thrust but need massive amounts of fuel, ion engines can attain high speeds with only a small amount of propellant. The basic principle behind the operation of ion engines is the generation and acceleration of ions. This phenomenon is governed by the laws of electromagnetism, which allows the creation of a stream of ions, which are charged particles, using a range of power supplies. After the generation process, these charged ions are then propelled at very high speeds up to velocities of 146,000 kilometers per hour using a high-powered electromagnetic field. This, in turn, generates momentum or thrust that propels the spacecraft forward. The main advantage of ion engines over conventional chemical rockets is fuel efficiency. Chemical rockets burn a mix of propellants to generate thrust upon combustion, whereas ions in ion engines are accelerated using electromagnetic fields. Chemical rocket engines require a large amount of fuel during the journey, all of which needs to be taken with the spacecraft. Ion engines, on the other hand, require only a minute fraction of fuel, which can last for several years of operation, making them much more efficient and feasible for long-duration space missions. Ion thrusters also provide a higher top speed in space. Deep space probes like NASA's Dawn mission and Japan's Hayabusa 2 mission used ion engines to travel through the solar system, and their speeds often exceeded tens of thousands of miles per hour. Also, Ion engines are unusually quiet as they operate without the huge combustion process associated with chemical rockets. One of the challenges with ion engines is that they produce low thrust compared to chemical rockets, which makes them unsuitable for high acceleration missions. But they are ideal for low thrust missions that require long durations, such as exploring the outer reaches of our solar system. They are not well suited to missions that require high acceleration over a short duration, such as launch vehicles for getting a payload off the Earth. To sum up, the development of ion engine technology is an essential area of research, and it is opening up a new chapter in space exploration. These engines represent the future of interplanetary travel, enabling spacecraft to achieve higher speeds and long-duration flights with greater fuel efficiency. The ion engine propulsion system provides the potential to explore and colonize deep space and help scientists answer fundamental questions about the universe. In conclusion, the future of space travel might be closer than we think. Ion engines provide a way forward in our quest to explore space at much higher rates of speed and efficiency. While there are still limitations, the development of advanced ion engines has become an important area of research, providing promising possibilities for more efficient and faster space travel.